Thank you all for joining us today. I'm Faith Sternlieb, Associate Director of Engagement for the Internet of Water Initiative at the Center for Geospatial Solutions at the Lincoln Institute of Land Policy. Today we have Mary Bucknell and Dave Blodgett here to present on the Hydro Network Linked Data Index journey, past, present, Python, and beyond. Before we get started, I'd like to cover just a couple of housekeeping items. We are recording the webinar today, so the recording and slides will be available on the IOW YouTube channel about a week after the webinar. So if you would like to refer to anything or share the webinar with friends and colleagues, you'll be able to do that in about a week. We'll also be taking questions throughout the webinar. So if you have a question at any point, please drop it in the Q&A. Not the chat, but the Q&A, and we will go through the questions after the presentation. If you have any technical issues, please put those in chat, not the Q&A, and we'll try to get that fixed as soon as possible. So now on to the main event. I am so pleased to welcome Dave Blodgett, a civil engineer with USGS Water Resources Mission Area, Integrated Modeling and Prediction Division of the Geospatial Intelligence Branch, as well as his colleague Mary Bucknell, a computer engineer out of the USGS Water Resources Mission Area, Integrated Information Dissemination Division of the Web Communications Branch. We're excited to have both of you join us, and we're really pleased that all of you who have registered for the event are here to join us as well. With that, let's get started.
All right. So it would be me. Got that. We got a screen going.
Yep.
There. Cool.
You are good to go.
All right. Well, thanks for coming along, everybody, and thanks for having us, Faith and Internet of Water Coalition. Really happy to be here with my colleague Mary Bucknell, who I don't get as many opportunities to work with recently, but I have worked with over the last, gosh, almost probably 10 years on and off on what we're going to be talking to you about here. And I was just curious to see where this all started, and I went to look at the commit history, and the first commit on this project was actually 8 years ago, under the at the time under something we were calling the Open Water Data Initiative, which predated the Internet of Water and was kind of a multi-federal agency initiative for open water data. And so over the last 8 years, this project has evolved and really proven out technology and shown what's possible. And for the presentation we're going to do here, we're not going to go into a great gory detail of the history of this system, the Network Linked Data Index, but we will kind of give a sense for what it's always been about and what it's about now, and hopefully give a little bit of an idea of where it's going. So this is around for the duration and is a capability that's going to be really core to the Internet of Water as we go here. So I'll go ahead and jump in. The Network Linked Data Index is a system that at its core is a application programming interface, but there's a number of components that relate to that interface. That the application programming interface is how software works from computer to computer, and at the end of the day, all computers essentially talk to each other over these APIs, but this one in particular has a lot more to it than just the interface. It has a collection of data and a collection of kind of supporting systems that work with it. And so to best understand that collection of data and systems, first we need to think about the use cases or the things that the system supports. And so probably the first and most important thing that the Network Link Data Index was designed to support is this question: what stream gauges are upstream or downstream of another one? We needed to be able to say, what's the next upstream stream gauge? What are all the stream gauges upstream? If I start at a given location that's not a stream gauge, where's the nearest measurement of stream flow? Just that core question requires a fair amount of sophistication to be able to trace a river network, know what stream gauges are on what river, these kinds of things. And then you need to be able to bring that to the internet and make it available from one machine to another. It's not just a single system. And so taking this one step further, where does the water at this location come from, right? So what's the watershed upstream of a given location? Both what's the network of rivers that might carry that water, what's attached to those rivers, and what's the landscape expression of that upstream area? What's the basin? What's the polygon boundary of a watershed, right? We could ask questions like, how big or small is the upstream basin for a given location? Are we on a big river? Are we on a little river? Is there additional information that we could attach to that query to understand additional characteristics of the upstream basin? And then finally, where does all this water go? Like what's going to be impacted when you go downstream from a given location? And that's been a really interesting question that people have found this to be kind of tremendous for, where you say, well, there was a spill. What's all downstream that's going to be impacted? One of the demos we've used over and over and over is the Gold King mine spill, where people needed to know, where's all the monitoring downstream of this location so we can track water quality characteristics, and what rivers are impacted so we can, figure out maybe what water supplies, what fishing habitat, what, et cetera, kind of locations that might be impacted by a water quality situation. So these are all pretty broad general questions that are served by this system that is intentionally general and broad. And to satisfy this set of questions, the set of data and capabilities that's required are as outlined at the bottom here. We've got a network, which is a set of connected entities. You have a network of roads, you have a network of rivers, you have a network of things. So there's a table in a database that says this identifier attaches to that identifier, attaches to that identifier in a network of flowing connected entities. There's a set of flow lines, so geometries that tell us something about the shape of the network entities. There's catchments, polygons, that tell us something about the area of land that drains to the incremental flow lines. And then there's this whole world of associated data. And a lot of that associated data is things like stream gauges, water quality observations, other information that you would think of as being along the river. But it's more than that. It's also associated information like incremental drainage area of catchments, landscape characteristics of those catchments, lots of other kinds of information that you can associate to the flow lines, like length or depth or slope, these kinds of things. All of this stuff can be thought of as linked data that in some senses characterizes this network of flow lines and catchments. And so we have this data set, and it's not a mistake that that's essentially NHD plus, for those of you who are familiar with that data set. At the core of this network link data index is a form of the NHD plus. And as this system goes forward, it will continue to have kind of this scope of data that's been over the years found useful for modeling and other applications. But then it also includes, a set of software that knows how to interpret all this stuff, and then a public API that allows you to access all this data via some software. So I went fairly slowly through that, tried to really kind of paint a picture of, these are the core use cases that this system was designed to 5, 6, 7, 8 years ago. These are the core use cases that it satisfies now and has been providing some basic support to various systems on over the years. And this kind of set of components it's important to kind of realize that this is what's behind the curtain. You've got tables of a few million entities that form a network, and we've got geometric representations for those entities, as well as this set of linked data that's then available via some software and an API. And there's a lot of complexity there, but there's a lot of complexity in all the systems that we work with on the internet these days. So it's nothing new. So I want to talk a little bit more about the, how we do this. And so this is the most recent work on the network and the underlying kind of data for the Network Linked Data Index. I think this DOI can probably get dropped in the chat for y'all to look up if you want. But this generating a reference network paper is one that came out recently, and the work that went into this is going to make its way into the Network Linked Data Index as kind of the next generation network for the system. So this updated network attributes, right? And we're still going to be in the NHD Plus version 2, which is the kind of a 10 or so year old best available national highly quality controlled network. We'll still be in that world for a little while. There's higher resolution networks on the way, but that's where we're at now. There's a set of catchment polygons that have been pretty significantly cleaned up, and we understand how to work with them much better than we did years ago. There's a set of flow lines that similarly have been cleaned up pretty significantly and are a much kind of more usable and more approachable quantity. And then we have a huge collection of community POIs that have been added to this reference network, and the paradigm for adding additional points of interest, additional linked locations, is really kind of formalized and has kind of come to fruition since the beginning of the NLDI. And this paper summarizes work that was done over the last 5 or 10 years, really, and there's a couple of key references to other work from this paper that go a little further back or a little deeper into some of the nuances. But I want to stress that, while this is a 2023 paper, it's documenting work that was done on the data that backs the NLDI that has been ongoing for the last 5 to 10 years. So this moment of the Network Linked Data Index is really a kind of we're coming out of what I'm thinking of as kind of a long drawn out research and development phase and moving into something of a operations and kind of ongoing operations and maintenance phase. So then let's talk a little bit. So this is the data and the backing the backing database part of the Network Linked Data Index. Let's talk a little bit about the internet part of it. And this is a diagram taken from this docs.geoconnex.us, which is an Internet of Water CGS, Center for Geospatial Solutions maintained documentation space about the system called Geoconnex.us, which is an outgrowth of a lot of the work that's gone on in this space, and this space being the Internet of Water, before that Open Water Data Initiative, and now moving into this current incarnation, it's the Internet of Water and Geoconnex.us. So this is a web architecture. The graphic, I would call this graphic a informal web architecture, let's call it that. And it's meant to give a sense for the pieces of information and the way they relate on the internet, and how we build the index part. You think of a search engine index like a Google index. It's how we build that part of the Network Linked Data Index. And so keep an eye on chat, make sure I'm not totally off track. Okay, cool, just links. So what you're looking at here, on the bottom, we have real world features or locations of interest. Think of this as dams or stream gauges or bridges or cities along rivers, all kinds of real world features, places and things. On the right, we have real world features that are locations of interest. And this is typically going to be environmental features. So things like rivers, lakes, aquifers, the real world features that make up the environment, essentially, or the things that we recognize in the environment. And so the kind of built environment features are related in some hydrologically meaningful way to real world features. And both sets of these features need to be referenceable by some kind of identifier, so that we can keep track of information about them, right? And that paradigm is super central to the way the internet works, and it's extended a bit to environmental data by some thinking that's been done for linked data on the internet in the earliest days by people like Tim Berners-Lee, who put forward kind of strategies for linking data to the real world things like people, places, and things that are not digital, but we have information about them nevertheless. And the strategies for establishing those linkages are really kind of key to this overall system. And so in both cases, we've persistent identifiers that are, in this case, URLs that are thought to identify real world features, whether they're environmental features or anthropogenic features. And then those URLs, instead of, obviously you can't, if you look a person up on the internet, you don't get the person back, you get a web page about them back, right? In the same way, if you look up a river on the internet, you get back a web page about the river, you don't get back the river. So if you have an identifier for a river and you look it up, what you're going to get is what we call a landing page. And that landing page is probably going to include something that's for a machine, this structured data, structured or linked data. And so this is, if you go to a restaurant's webpage right now and open up the source for it, there's going to be some structured data in that webpage that's of interest to Google. And the exact same applies to the landing pages that are being built out for ingestion into the data index behind the network link data index. So the paradigm here really is that the network link data index is a search index in the way that Google maintains a search index over the features and the information that are described in this architecture. And it's all should be fairly familiar to people who use the internet a lot and are familiar with ideas around search engine optimization. We're really kind of copying that successful paradigm. But what's not familiar is that typically data providers and environmental data systems don't operate as web systems. They operate as databases or models that run in their own environment. They don't have this exposure on the internet. And this is what the NLDI, when we started, was assuming was the future. This is basically what we call an open world, and the internet as an open world where basically everything is exposed to everybody, and the crawlers can find it and index it, right, is the paradigm. So I'm gonna move through this fairly quickly. I just wanted to throw this up there. There's one of the links I was going to have Faith and co-share points to an about the NLDI page that describes this in detail. But this is the application programming interface kind of pictogram for the NLDI. And what I want to point to is, the use cases I talked about up front, the ability to look up a stream gauge and figure out what's upstream or downstream of it. Well, in this set of the API, the feature source could be NWIS site, so National Water Information System site. And the feature ID might be a stream gauge identifier. And then you can look up the basin. So what's upstream of this basin? You can look up catchment characteristics about that basin. You can navigate upstream, downstream, upstream with tributaries, upstream just the main stem. And then this data source is maybe other NWIS sites, maybe the flow lines, so the linear geometry that's upstream of or downstream of a stream gauge. And so using this API, this basic URL syntax, we can say search from this type of feature with this identifier, some navigation mode, and return whatever data is available in the system. And that basic pattern allows us to kind of construct these queries and construct a way of navigating and discovering information. And then there's a few other kind of support things. You know, we can look up an identifier by position. We can, you know, there's other kind of supporting metadata information, but really the core of it is this navigation endpoint that you can create navigation queries in a really easy and flexible way. And then the extension, and that this, and I don't think I can't actually copy that. I'll drop this in the chat when I'm done. There's another blog, but there's a blog post, and we'll be dropping a link to this blog in a moment. That's this NLDI processes blog that talks about these capabilities. One allows you to come in and drop a point on the river network and get a local catchment split precisely to your point. So if your site isn't one of the already available locations in the NLDI, you can kind of split the network very precisely using an elevation surface and get back a polygon that's representative of the local catchment or the local basin that's very precise to your point. And there's also utilities that allow you to pull a cross section across a valley and get back the kind of cross-section geometry across a given valley. And these are important, you know, these are used by systems that need to establish, you know, precise drainage area relationships for stream gauges and other information, like the stream stats system. And yeah, so that blog that was just shared in the chat, there's a number of blogs about the NLDI, as well as some of the stuff that Mary's going to talk about next. And I'm going to close out and turn it over to Mary here with this. So if you Google NLDI GitHub, you'll find both of these repositories. It's in the Internet of Water organization. So this is the broader kind of Center for Geospatial Solutions maintained Internet of Water GitHub organization. NLDI crawler, NLDI services, both of which are now written in Python. The original NLDI was written in Java, and we're going to be evolving the NLDI API to be simpler, more streamlined, faster, and we're going to be providing some of the current functionality in other ways. So one of the things that's been available for a while, but is difficult to maintain and doesn't scale real well, is this catchment characteristics endpoint that I mentioned in passing. So a couple of these endpoints are going to go away. We'll kind of reduce the potential for confusion of what the NLDI is supposed to be used for, and allow us to satisfy these much more directly. And as part of this refactor, part of this rewrite, the overall NLDI is going to be much more approachable for open source contribution. So this NLDI services and the NLDI crawler repositories, which are the services, is what presents this whole API. Crawler is what goes out to data sources and brings them into the NLDI database. Those are both available now for contribution in Python. I would very much appreciate folks opening issues and opening up discussions there if there's things you're interested in the system being capable of in the future or changes you'd like to see. Please do look us up there and interact. But other than that, I think that's what I want to cover. Hopefully we can leave a little bit of time at the end for discussion. I didn't want to go too far down any rabbit holes here, keep this fairly high level, but also give a good coverage of the system. So I'll stop there and turn it over to Mary.
Thank you, Dave. Just to give you a little bit of background about myself, I'm actually more of a technical person. My focus in the last 6 or 7 years has been developing data products such as this monitoring location page to start replacing the old USGS NWIS legacy sites with a new product called Water Data for the Nation. But just to show you how long I have been around, I do have commits to both of those repos that Dave gave links to, both the NLDI crawler and the NLDI services a while ago. Now my focus is more on using the APIs to give our users more context about what they are looking at and the ability to explore our data, explore our sites, and find the data that they need to do whatever it is that they need to do. So as I mentioned, we are modernizing the USGS NWIS web presence and rebranding to Water Data for the Nation. So that's what the WDFN on this slide stands for. Rather than replacing all the legacy content at one time, we have chosen to replace the most used pages first, starting with pages that show current conditions and other information at a single monitoring location, such as this one for the oldest gauge in the USGS, the Colorado River at Lee's Ferry. We have a graph. If you page down on these, it has a list of what data is available at this site. It also has a map that will show where the site is located and give the user some context about what is around that site. Are there cities or streams or lakes or roads nearby? And I'll talk a little bit more about how we use NLDI on that map in a bit. Could you go to the next slide? So part of our process, the team that I lead's process, in redeveloping these pages is we talk to current users of our pages, of our products, and we want to figure out what they come to our site, why they come to our site, and what questions are they trying to answer, and perhaps what questions aren't we answering very well at the with the current website. So these are just a few of user stories that we have actually heard users talk about. So as a recreational kayaker, I want to find sites upstream from my location so that I can determine if the water level is safe for kayaking today. As a research hydrologist, I want to see what landscape features are in the upstream basin from my site so that I can determine what could be affecting water quality data at my site. And as a modeler, I want to find sites downstream of my site so that I can use those sites' data as part of the data set used to develop the model. Next slide. So the NLDI can help answer some of these questions. Here is an example of a site that is actually close to my home. And on this map, we show these red dots are active sites within the NWIS network. And on the map, we put the upstream basin, which is the gray area, along with the upstream flow line and the downstream flow line. The upstream flow line is the dark blue and the downstream is the light blue. And in this particular case, if you went to this website, you would see that those flow lines actually continue past what you can see on this map. But it allows the user to say, hey, I want to see that site that is upstream from my site. Maybe I can get some information from that site's monitoring location page. If you click on these red dots, you get a link to the page. So this is a way that our users can explore our data and find other sites that might interest them and that should help answer those questions that I listed on the previous page. Next slide. So we do have future plans for NLDI. As I mentioned, we are in the process of replacing legacy website or the legacy pages within NWIS. Currently, we are working on one that we call My Favorite Locations. And the idea of this page is to let the user discover sites that are related and then save that list of sites and use it to access current conditions, other available data, search for data, and to access some graphing tools that we have online. This feature is in its infancy, and in fact, we are doing user testing this week on the page, but this shows an example of a custom list that in this case has 2 sites in it. I wanted to see gauge height and discharge. We have the latest value. You can get some other information. At other places on the page, it links to other parts of our website that can get you to the monitoring location pages, can get you to some graphing tools. It can get you to our water services data. But as I was actually doing this presentation, I was thinking this is going to be a great opportunity to use NLDI. The next step is going to be to put a map on this page to allow users to explore not only where the sites that they've chosen are, but perhaps picking other sites that are related to the one that they have on the list already. And NLDI can help answer those questions. We can provide the map. We can use the navigation API to tell exactly what sites are upstream or downstream from a particular site. So I'm looking forward to exploring what else we can do with NLDI on water data for the nation. Next slide. I have also worked on the water quality portal, WQP, which provides the ability to retrieve water quality data from both EPA's STORAT and USGS NWIS data sources. Water quality portal has a really nice feature that allows one of the query parameters to get data to be an NLDI navigation link. And there's an example of one on this page. It's very large, but doing it this way means you don't have to put every site ID in the URL. You can just put the NLDI navigation URL, and water quality portal goes and fetches those sites and then retrieves the data that you want for those sites. So kind of a creative way of using NLDI within another system. So I hope that this has sparked some ideas about how you might want to use NLDI. I think it's a really wonderful tool. And as I said, I'm looking forward to expanding water data for the nation's use of NLDI in the near future. And that's all. I'll send it back to send it back.
Thank you both. Dave, are the 2 of you done presenting? Wanted to see if it's time to open it up to questions.
So,
Yep.
yeah.
Okay, great. We do have a few questions. The first one, and I believe, Mary, this is for you. Will this effectively replace StreamStats? If not, how do these 2 sources differ?
StreamStats is short-term networks, and it will not be replacing StreamStats. The work that we're doing is to replace the legacy NWIS, which stands for National Water Information System for USGS. It's to replace those pages. So those are the ones that are public that I guess StreamStats is too, but those are for short-term sites. Sometime in the distant future, that might be a part of water data for the nation, but that's not on the, you know, like it's not in the next couple of years kind of thing.
Yeah, I'll speak a little bit to that too. The StreamStats product, so the same team, actually Mary, the same team that does the short-term network builds StreamStats.
Yeah, yeah.
And they're both separate from water data for the nation. And so the StreamStats product, which is so StreamStats does use the NLDI as a resource, and it's all about streamflow statistics at sites that are ungauged or have a limited gauging record. So what we talked about here could augment StreamStats, and in some future, those capabilities may become part of water data for the nation, but that's not anything that's being planned at this time, at this stage. So, and short-term network is another StreamStats adjacent product that's all about, you know, short stream gauges that are deployed for a short time, like during a storm, but don't become part of the core NWIS stream gauge set for one reason or another. And that's another set of information that kind of is in this sphere, but is not necessarily core, kind of part of the water data for the nation brand. So.
Thanks for the clarification, Dave.
Nobody can keep track of any of this stuff.
It takes a village, as you pointed out. 8 years in the works, and probably, and then some conceptual ideas first, I'm sure, a few years before that. So another question for the two of you, two-part, do you plan to support a USGS app? For example, to use the app to search for sites like hiking near me, for example?
So there's no specific plans for a NLDI client, if you want to think of it that way right now, that's general. There are a variety of script utilities that allow you to work with the NLDI. So there's High River is a Python package that has a client that would allow you to build your own app or you know, create a notebook that made those queries. There's NHD Plus tools and data retrieval are R packages that both use the NLDI for a similar application. So there's there's more in that space. There's no web app at this stage that's general. That said, I could see that happening. There have been a handful of very lightweight JavaScript map clients created for various experimental and kind of demonstration or development purposes. I could see one of those emerging in the not too distant future, but I don't have any specific plans to share on that.
Okay. Great. And I wanted to remind everyone, feel free to put your questions in the Q&A, and we will get to it. In the meantime, I have a question for you. So for people who would like data that's not already in NLDI, where should they start looking for those data?
So there's a couple of entry points. The first one is just reach out in the issues of the NLDI crawler repository. If you're kind of a data scientist or a developer who's in that world already, just reach out, get in touch, and we can start a conversation about the data set or data sets in particular that need to be considered. The other answer is, if the data are associated with NHD Plus version 2 already, all we really need is a GeoJSON table available publicly, and we can point our crawlers at that and pull the data in. So the technical answer is GeoJSON associated with COM IDs or reach codes from NHD Plus version 2, and really just get in touch, and we can start a conversation about how to get things added. There's a variety of organizations have data in the NLDI now and use it for their own purposes, or making their data available to whoever wants to get access. And we're really excited to keep growing that as we go here. So.
And Dave, who would they get in touch with and how? One of you or
yeah, so issues
else?
on those repositories are going to hit my inbox. They're going to hit some folks in the Internet of Water team at CGS, and we can kind of triage from there and help people along. So
can we share your email address in chat with folks?
Yeah, feel free. If you Google me, you'll find my address, or I'll chuck my email in the chat for sure.
That'd be great. Thank you. We do have another question from the audience. Does the NLDI work for Super CONUS? Is there a timeline for extending the network to Alaska? Crickets.
Working on it. Okay, so there is a project. So the paper that the DOI for it is up in the chat, talks about the work that it got completed last year. This year, we're working with the 3D hydrography program, part of the National Geospatial Program here in the USGS, to expand the reference network to include the parts of Canada covered by NHD plus high-res. And so that's the Super CONUS in my worldview. The full US domain to include Alaska and potentially islands is a little bit further out. There is a world where we add Alaska in a limited capacity soon, but we don't have catchments for Alaska. And that one of the key ways to get data into the index is to do a catchment index, which is where you put a point in the catchment and say, ta-da, we index the point to the network. Which is functional. It works. It only goes so far, but it works. We can't do that in Alaska. And so the number of or less than appropriate indexes would be pretty high if we went down that road in Alaska. So that's where we have to be careful how far we take it. But that's where those two stand. I would expect Super CONUS within a year or a little more. Alaska, if somebody says yes, do it, even though it'll have some drawbacks, we could just do it. But somebody's got to say yes, do it, and it's got to be clear that there are some pretty heavy limitations.
Somebody like who, Dave?
That's a really good question.
You on the spot.
That's a really good question. It's not entirely. So at this stage, it would be a group like the 3D hydrography program. What is the name of the group? There's an interagency 3D hydrography program steering group that would say, yes, we want to see the 3D hydrography program flow line network in the Internet of Water. That kind of a group and they would be bringing feedback from stakeholder groups to make the call that yes, we want that asset presented in that way. It's also just a matter of somebody having the time and money to do it. So that's the details. Okay,
great. Thanks for entertaining the deeper questions, Dave.
Very good questions, and I know a lot of people have them. It's important that it's important we're clear about kind of where all that's at. So, and
I guess just in case anyone on this on the webinar is part of that group or who watches this later knows that it is they who can get that started in the pipeline.
An awful lot of competing priorities out there.
Yeah, for sure. And then for both of you, I have another question. If people want to learn more about water data for the nation and its services, where's the best place to go?
So the best place to go is our blog, which is at waterdata.usgs.gov/blog. We do.
I think we shared that.
Yeah, I think so too.
Yeah, in the chat.
Yeah, it's in the chat. We make regular announcements on there of new features. We also would appreciate if people are using our pages and they have some feedback, click that questions, comments button, and somebody reads that. And we also, if you're interested in doing user testing with us on any of these new features or on any of the new pages, click that questions and comments button, and your name will appear on a list that we can use to for our user testing. So I will also say that our plan is to revamp water services. We actually have a new testing tool, but the services that are behind it are still the legacy services. Intention is to modernize the services as well, and provide data in more standard formats.
Yeah, I was gonna, if you mentioned it, but I was gonna say, if you haven't seen the new face of waterservices.usgs.gov, the landing page of water services was recently updated to the new web standard. And the transition to the new water services has begun, which I'm personally very excited about. So, and being available to help test this stuff is more valuable than people can possibly imagine.
Yes.
Really,
Yes.
really need people to engage on testing and help us get this right. So
Yes.
So Dave, on that point, on the testing point, would people volunteer to be testers, or are you asking for volunteers? Are you contacting people to to ask them to help you test? How would we do that?
I think Mary's probably got a closer understanding of that process than I do.
Yeah. As far as the user testing of the website and the services, the best thing to do is to contact us. There's a question and comments link on all of those new pages. And we do read those and respond. But if you're interested in participating in user testing, we are happy to take your name. And as I said, we've talked to all kinds of people, not just scientists, not just modelers. We've talked to recreational paddlers. We've talked to fishermen. We've talked to homeowners who, they know what site is near them, and they know if the gauge height is a certain height, they aren't going to be able to go across the bridge to work.
Mhm.
So, I mean, I have found it fascinating to talk to people about how they use our data. It has been surprising in a lot of ways.
Yeah. Yeah, and I would add, I mean, we had some firewalls update on us last week, and there's a couple of endpoints on the NLDI that currently don't work because of it. The core endpoints work fine, but there's an ongoing thing we're debugging. And I'll just say, like, the half dozen people that have reached out saying, hey, things are not quite right. Like, yeah, we know they're not quite right, but it's really valuable to hear from people that the patterns they're using aren't working, or things aren't working quite right, or things could be better. And that's why I stress, meet us in the issues, because this is all basically open source public domain work that is, it's in the interest of everybody. And the more engagement we can get, the better we can do for everybody. So,
for sure. We do have a couple other questions for either of you, it looks like. Does the NLDI index contain just point data or other data?
at this point, the reference for a given indexed feature is a point. So whether the data in some senses is not just a point location, the system has a point for it. There has been some work to allow us to index other types of geometry that would allow us to say, this wetland is indexed to a river, and the wetland is represented by a polygon. We haven't actually we haven't indexed any data with additional data types though. So the capability is there, we can expand it. If there's good, strong use cases for it, it is possible. But right now that's not been leveraged. So.
Great. All right. Mary, anything to add?
Nope.
And then another question, what is an example of high value use case that hasn't yet been implemented, but is within the realm of possibilities?
So the one that I really want to get done that's not hard is the ability to leverage the sort order, the upstream downstream order of the river network, both to provide an ordering of the points you get back, the locations you get back, or to do things like go to the next upstream, go to the next downstream, these kinds of things. There's some nuanced attributes that are in the database that aren't exposed via the API that we could, if we exposed them and made them available and documented them appropriately, could be very meaningful to some use cases. That said, there's a strength to simplicity, and that's the NLDI has always been that. Like we've been very hesitant to add anything because we know everything that gets added just compounds the complexity to new users and to applications that don't need the complexity. So we need to be careful. But the probably the thing that I would call out is like it doesn't do it now, and it'd be really meaningful is the upstream downstream sort of the features you get back. So.
All right. We, as you all might have seen, we shared a kind of post-webinar survey, so we appreciate you filling that out. I think Dave and Mary, if there's anything, is there anything else you'd like to finish up with before I close out?
No, just
thanks a lot.
Yeah, thanks for the opportunity to talk to you all about this.
No, and we appreciate, I mean, this is monumental. This is like huge. I feel like we need fireworks, and we need we need some like champagne, and we need I mean, we need to celebrate this. So like this webinar, you know, I don't know, maybe we'll have a post party or something, a post webinar party for the work that you all are doing. Of course, in collaboration with us and so many others, right? This is kind of a like I mentioned, a village. It's a village to figure out these puzzles that are in front of us in order to help us make, you know, better decisions, better water data, more accessible water data, better decisions. So thanks so much to the both of you for your work on this and for sharing where you are at with this. And then thank you, the audience, for joining us for today's webinar. Remember to be on the lookout for the recording in a week or so on the IOW YouTube channel. But if you have any questions in the meantime, feel free to reach out to us directly with any questions you may have about the Internet of Water Coalition, about Geoconnex, about any of the work that Dave and Mary presented today. And remember, these webinars are a platform for you all to share your work and expertise across the IOW community, water data community, whether you're a water data provider or user or both. We welcome any ideas you may have to present to the community. Please let us know, and you can email our team at internetofwater@lincolninst.edu. Thanks so much again, Dave and Mary, to both of you for your work and for sharing with us your work. And thanks to all of you for joining us today.